Okay, so if you have gotten to problem number 14 and say, oh no, Miss Nog-Dave, I don't know what to do when I have a variable on each side of the equal sign. Well, lo and behold, Miss Nog-Dave has a solution for that. And yes, I do have kids coming back from PE. You guys like to think that we are doing nothing. But we are not doing nothing when you are gone at PE. We are still working. So if I write down this problem, I've got 4k plus 44 is equivalent to 10k minus 10. So yes, indeed, I have variables on each side. Now recall, this actually means 4 times k. So there is an operation here. What we always want to look for is like terms. Well, lo and behold, 4k, 10k, those are like terms. We're going to try and get the variable onto one side and numbers on the other. In this case, you always want to be cognizant of what would give you a negative number. And that's something we don't want to work with in 5th grade. You will get plenty of that next year, integers next year. So for now, let's take a look at our options. We could use inverse operation to remove this k and get it to the left side. To do that, I would consider this a positive 10k because there's no sign in front of it. Therefore, I know that it is a positive, and I could say minus 10k. And then when I come over here, minus 10k. However, I probably don't want to use that because positive 4 minus 10 is not what we want to be working with. Make life easy this year while we can. However, if I do the inverse operation here and knowing that if there's nothing in front of this variable, then it is a positive, I would do the opposite, which would be negative 4 or minus 4k is how I should say it. And if I do it on this side of the equal sign, I also must do it on this side. So I'm going to do subtract 4k. Just looking at this, 4k minus 4k is going to give me 0 k's on this side. We just wiped that out. And with algebra, we always rewrite our problem. So I'm going to come straight down. That's now gone. 44 on this side of the equal sign equals. Now, on this side, if I have 10 letter k's, because remember, this isn't a number 10. It is a coefficient telling me that I have 10 k's, 10 letter k's. And I'm going to take away 4 of them, leaving me now with 6 letter k's, or the variable of k, and minus 10. Okay? From here, now I've got my variable on this side. I've got a number here, minus 10, and a number here, 44. What I want to continue to do is try to get the numbers on one side, the variable on the other. And in this case, rather than taking the 44 and moving it that way, I'm going to take my minus 10 and do the inverse operation, which would be plus 10, and therefore plus 10 on this side. And again, I'm going to rewrite my problem. So 44 plus 10 gives me 54. Rewrite my equal sign, equals 6k. Minus 10 plus 10 cancels itself out, nothing left there. So now my equation is 54 equals 6k. Now, don't forget, there is actually an operation here. There's no operation on this side. It's just the value, number 54 equals 6 times k. So there is an operation on this side, multiplication. And to solve for this, I need to do the inverse operation, which means if it's multiplication, I'm going to divide by the 6. But if I do it on this side, I must also perform it on this side. So 6 divided by 6, well, we know that cancels each other out. Bye-bye. You're left with just k. And 54 divided by 6 gives us 9. So then our final answer, and to answer algebraically, it would not just be 9. It would be 9 equals k, or we would normally rewrite that as k equals 9. We would say the variable first and have the value of the variable. Okay, so let's look at this again, because if we were to go back in and apply this, so let me rewrite from the beginning. 4. Now if k equals 9, instead of the k there, I'm going to do 4 times 9 plus 44 equals 10 times 9, k equals 9, minus 10. So when I come back to solve, we want to make sure that what's on this side equals what's on this side. And I have 4 times 9, that's 36, plus 44. Ooh, well, that is the value of 80. And then I've got 10 times 9, which gives me 90, minus 10, and that is the value of 80. Therefore, I have 80 equals 80, and that is a true algebraic statement. Okay, see if you can solve the other problems on the page. Good luck.